Okay, for 28 through 30, we're writing equations of the line given some information. Here we have a line that goes through the point 3, 2 and has a slope of 2, so it's going to look approximately like that. Just trying to get some visual on what it is our target is. So most students like to approach this with slope-intercept form. We know that y equals mx plus b. Here we know that m equals 2, so we can go ahead and just write that in there, 2x plus b. What we don't know is the y-intercept, but we can use this point to find it. We know that that point is on the line, so if we plug it in for x and y, we should be able to get the y-intercept. So we know that x is 3, y is 2, so let's go ahead and plug that in. 2 is y times 3 is x plus b. 2 equals 6 plus b. Subtract 6 from both sides. B equals -4. So that gives us our y-intercept. And we can go ahead and write the line as y equals mx plus b. Number 29, slope is 0. Well, we know right now that that slope of 0 is going to either be a horizontal line or a vertical line. So we need to do some thinking about that. Well, if it's rise over run is 0, it means there's no rise and lots of run. So it's going to be this. This slope is undefined. So this one's really straightforward to reason through. We know the point is 2, 2, and it's a horizontal line that's got to go through that point. So it's going to just be the value of whatever that y-coordinate is. So y equals 2 is the line. And 30. Again, we'll use the y equals mx plus b approach here, mx plus b. Problem here is we don't know the slope or the y-intercept, so we need to do some work. The first thing we'll do is go ahead and get the slope. If we have these 3 points here, we have 3, 6 up here, and we have -9 and 2 up here. So we can use those 2 points to find the slope. Now if you remember, slope is change in y, which we can write as y2 minus y1, that's the rise, over the run. So we're just going to do change in coordinates here. So we'll use this as our point 2, and we'll use this as our first point here. So y2 is 6, y1 is 2, and then x2 is 3, and x1 is -9. So 6 minus 2 is 4, 3 minus -9 is 12, 4/12 simplifies to 1/3. So our slope is 1/3. We are halfway home. We need the intercept now, and we can use that same approach we used on the earlier problems. I'll go ahead and use this as our point, xy. So if we know that y equals 1/3 x plus b, and this point is on the line, so 6 is the y value of that point, 3 is the x value of that point, that will equal b. 6 equals 1/3 times 3, which is just 1. Subtract 1 from both sides to get b equals 5. And so we would get y equals 1/3 x plus 5. Now in the answer key, I did this in point slope form. I found the slope the same way, and if you're a fan of point slope, we know that we can take point slope is y minus some y value from a point equals the slope times x minus some x value from a point. And we could use that same point of 6, 3, or 3 comma 6, the x value is 3, and we'd get y minus 6 equals 1/3 x minus 3. That's what's on the answer key. And if you actually did some algebraic simplification, you'd see that those two are equal. So either way is fine. I find most algebra students like to gravitate toward this slope-intercept approach. One, more equations of lines. We want to write an equation of a line that passes through this point given, which we can sketch in here as -4, +2. So that's the point given. And we want a line that goes through that point that's perpendicular to this line and parallel to that line. So the first thing is we just need to find the slope of that line. So in order to do that, let's put that thing in slope-intercept form. So x minus 2y equals -2. -2y, I'm going to subtract x from both sides. And we'll divide both sides by -2. Y equals 1/2 x plus 1. So we see that the slope of this given line is 1/2. So if a line is parallel to another line, they have the same slope. So I'll write that down here. Parallel equals same slope. And then perpendicular is opposite reciprocal slope. So we'll start with the line that's parallel. So for parallel, we know that m will be 1/2. So that line is going to be 1/2 x plus b. We don't know its y-intercept. We're going to use that same approach we just used in 30 and 31, is put that point in there. So the y value of that point is 2. The x value of that point is -4. Now we can solve for b. 2 equals -2 plus b. b equals 4. So the line that's parallel is going to be y equals 1/2 x plus 4. And then the perpendicular line is going to have the slope as the opposite reciprocal. So the given line has a slope of 1/2. The opposite reciprocal of that will be, reciprocal of 1/2 is 2, and the opposite of 2 is -2. So we're going to do the same process now with the slope of -2. So we know that y equals -2x plus b. Just thinking of that same point being on the line. So we have got to plug in the point. The y value of that point is 2. The x value of that point is -4 plus b. We have 2 equals 8 plus b. Subtract 8 from both sides to get b equals -6. And so the perpendicular line has the equation y equals -2x minus 6. And those are the two solutions.